All right, let's get rolling with page 28. Number 140. Find the diameter of a cylinder with a volume of 312 cubic centimeters and a height of 6.8 centimeters. Round your answer to the nearest hundredth. Okay, let's go to the ask of the question. The question says, find the diameter of a cylinder. So I'm going to go ahead, I'm going to box this in. I'm looking for the diameter of a cylinder. Now, you need to know that 99.9% of our formulas do not use diameter. They use radius. So what you should automatically think to yourself is, I'm not going to look for the diameter. I'm going to look for the radius, and then I'm going to double it. So right now, I'm focusing in on the fact that I have to do 2 times the length of the radius. So really, I'm looking for R. Now, let's think about what shape we're talking about here. They're looking for the diameter of a cylinder. Okay, let me go ahead and draw my cylinder. Okay, so this is my cylinder. I'm looking for R. And they tell me a couple of things about this shape. Let's take a look at what they give me. They're telling me my volume is 312 cubic centimeters. So V equals 312 centimeters cubed. Next, they're telling me the height is 6.8 centimeters. Okay, let me put that in. 6.8 centimeters. My final answer needs to be rounded to the nearest hundredth. Okay, so let's go back. Now, you have to think to yourself, if they give you a volume or a surface area or a circumference, if they give you something that uses a radius or a height in order to get that volume or circumference or area, then this is a problem where you're working backwards. Okay, so you need to ask yourself, how did they come up with 312? What formula would they have used? And when you're looking at a cylinder, the generic formula for volume is big BH. Because remember, it doesn't have a big point at the top. So you don't do divided by 3, just regular big BH. And remember that big B is not a number. It's the area of your base. So it's hiding an area formula behind it. Since our base is a circle, we're going to replace big B with pi r squared, which is the area of a circle. And then bring down the height. So now volume equals pi r squared h. Notice our r just made its first appearance. We're going to look for that r as long as we have every other variable in this equation. So let's take a look. Do we have the volume? Yes, we do. It's the 312. Pi is a number. R is what we're looking for. And now h. Do we have the height? Yes, we do. It's 6.8. So if we have all the other variables except for r, we can solve for r. So let's go ahead and get started. 312, I'm plugging that in for v, equals pi r squared h. Oh, let me fix the h. It's not h. We know our height. Our height is 6.8. Okay, so I want to get r squared by itself, which means I need to get rid of the pi and I need to get rid of the 6.8. The way that I'm going to do that is I'm going to divide out the pi and the 6.8 at the same time. So I'm going to divide both sides by pi and by 6.8. I could do it one at a time, but no need. Let me just get it done all at once. 6.8 on the right will cancel, pi will cancel. Now the same thing to the left. Pi and 6.8. Now you should know that this is not going to get you a pretty number. Let's take a look at what it looks like in the calculator. So 312 divided by pi equals, and now to divide by 6.8, click divide again, and then the 6.8. So you divide one at a time. Okay, so it's about 14.60 yada yada in the calculator. Okay, now I'm going to go out about 4 decimal places when I write it down, but I keep it in my calculator without rounding it. Okay, it's still in there, exact. So I'm going to write down 14.6048 approximately is equal to what we have left on the right, which is r squared. And now we need to get r by itself. So to get r by itself, we have to get rid of the squared. So we're going to square root both sides. Square root the left, square root the right. The 2 and the square root cancel, so we're just left with r. And in the calculator, let's go ahead and do that. So square root 3.82, so it's about, let's go have 4 decimal places. So 3.8216 is equal to r. Great. That's not my final answer though. Remember what we said. We want the diameter. So now we have the radius. We're going to double it. Okay? So in the calculator, it's still exact. You have it rounded because it's still in the calculator. Click times 2 equals. Okay, so that is our diameter. We need to put that one to the nearest hundredth. So my final answer is 7.64. And in terms of my units, it's a length, so it's centimeters. And we're done. So remember the key for this question, this is a working backwards problem because they're looking for a length, in this case the radius or the diameter, and they give you volume. So you have to think about what's the volume formula, plug in what you know, and work backwards using your algebra skills to get the radius. Okay, let's move on. Number 141. A cylindrical aquarium container holds 387 cubic meters and has a height of 12 meters. What is the radius of the container to the nearest hundredth? Okay, let's focus in on the ask of the question. It's asking you, what is the radius? So again, this looks like a problem where we're working backwards to figure out a length that's missing. Now let's see what we have. Start from the beginning. We have a cylindrical aquarium. Okay, let's go ahead and draw that. It's always great to have a visual. So here's our cylindrical aquarium, and this container holds 387 cubic meters. This word holds is telling you volume. If that wasn't enough, the fact that it's cubic meters, meters to the third power, is the second way that you know they're giving you volume when they give you the 387. Volume. So we're going to write down V equals 387 meters cubed. And they also tell you that the height is 12 meters for this cylinder. My ask in the question is what's the radius? Straightforward. You don't have to double it because they're not asking for the diameter, just what is the radius? And you want to round to the nearest hundredth at the end. Okay, so again, think to yourself, how do you get volume? How do you get volume of a cylinder? Again, very generic formula. V equals big BH, because there's no point at the top. We're going to plug in big B, which is the area formula for a circle, since our base is a circle shape. So now let's replace this with V equals pi r squared h. And now we want to solve for the radius. So we want to check to make sure we have all the other variables. We do have the volume. It's 387. We don't need to find pi because that's just a number. And we do have the height. It's 12. Okay, so let's plug everything in. Let's work backwards. Let's solve for r. So here we go. We have 387 for the volume equals pi r squared, and then our height is 12. Okay, let's start. We're going to divide both sides by pi and 12 to get r squared by itself. So both sides, we're going to divide the pi and the 12. Pi and the 12. Pi's will cancel, 12s will cancel. Now on the left, let's see what we get. 387 divided by, let's see if I divide by 12 first, if it'll be a pretty number. Okay, so about 32.25, and now that needs to also be divided by pi. So divided by pi equals, well, that's definitely not a pretty number. So let me go ahead and go out 4 decimal places approximately. So 10.2654. 5 equals r squared. Last step, we want to get r, so we're going to square root both sides. So the square and the square root cancel. And now in the calculator, just click square root. So that is our exact answer, and we want to round this to the nearest hundredth. So 2 decimal places. 3.20 equals the radius. 3.20 meters is your radius. A second problem where we've had to work backwards. Again, they gave us volume. We had to find r, so we laid out the volume formula right here, plugged in what we knew, and went backwards to solve for that one variable r. Okay, let's keep moving. Number 142. Now this is a little bit of a strange question. Let's see how we do. The bed of a wheelbarrow is in the shape of a rectangular prism. Okay, so we're looking at a rectangular prism. Tommy was working in the yard, transporting dirt to plant his new garden, and had to make 3 trips back and forth. Tommy is thinking of purchasing a new wheelbarrow that is larger and will only require Tommy to make 1 trip to transport all the dirt. So before he was doing 3 trips, now he wants to get something bigger, so he only has to do it once. How much wider will the wheelbarrow have to be? How much wider? Okay, let's visualize this. I'm going to go ahead and draw a wheelbarrow. It's going to be absolutely breathtakingly beautiful. Here we go. Here's my rectangular prism. And then my handle would be here. Then maybe I have some wheels here. Okay, perfect. Amazing. Okay, now, when we're talking about how much something can hold, right? The dirt's going in, so how much it can hold, we're talking volume. So again, you're thinking to yourself, well, to get the volume of this wheelbarrow, you would do the generic formula for anything that looks like a box, any rectangular prism, which is length times width times height. Okay, so we have length, we have width, and then we have height for this wheelbarrow. Now we want the new wheelbarrow to hold 3 times the amount so that he only has to make 1 trip. So we're looking to triple the volume. So our volume should be 3 times the regular volume of length, width, and height. Now they're only looking at changing 1 dimension. They said how much wider will it have to be? So all they're going to do is change the width, nothing else. So how would we change the width in order to make this volume 3 times larger? Well, if we just tripled the width, then we would triple the volume. Take a look. So if now my width was 3 times, or 3W, I would have length times 3W, 3 times the width, times height. And this turns out to be the same thing as we looked at before. The 3 goes to the front because it's our only number. All these other coefficients are 1. So 1 times 3 times 1 is just 3. Times length times width times height. So if we just triple one of these dimensions, we have now tripled the volume. So our answer is going to be, how much wider will it have to be? 3 times wider. 3 times wider. Okay, and we're done. Let's keep moving. Number 143. Get ready. This is a little bit of a longer question here. Daniel is choosing between 2 ice cream cones. Cone A has a circumference of 6 pi inches and a height of 9 inches. Cone B has a circumference of 8 pi. The advertiser claims both cones hold the same volume of ice cream. What would the height of cone B have to be in order for the 2 cones to hold the same amount of ice cream? Round your answer to the nearest hundredth. Okay, let's focus in on the ask of the question. What is the height of cone B in order for the 2 volumes to be the same? All right, let's lay out our information. So going back to the beginning, Daniel is choosing between 2 ice cream cones. So let me go ahead and draw 2 different cones. Here's our first cone. I'll call this cone A. And they're telling us cone A has a circumference of 6 pi inches. So I'm going to write down circumference equals 6 pi inches. And a height of 9 inches. Okay, so the height here is 9 inches. Then we have a second cone, cone B, that has a larger circumference, a circumference of 8 pi. So that means it's going to be wider. Remember, circumference is like the perimeter of a circle. So the larger the circumference, the bigger the circle. So I made this one a little bit wider. I'm calling that cone B, and I'm writing down that the circumference is 8 pi inches. And now they're asking me, what is the height of cone B? So I'm just going to put H for the height. Now, one thing that they tell me that's really important is that the two cones hold the same volume of ice cream. They have the same volume. So the volume of A is equal to the volume of cone B. Now, this is one of these problems where you have to work backwards. We're trying to solve for a height. We're talking about volume. We probably can get the volume, and we have to work backwards to get the height. The issue is we don't have enough information for cone B to get the volume, but we do have enough information from cone A to get the volume. So our game plan right now is go ahead and get the volume of cone A, and then once you get the volume, you can set it equal to the volume of cone B, work backwards, and get H. So lots of steps here. So remember, first thing we're going to do, let's go ahead and try to figure out the volume of cone A. And then it's going to be the same as the volume of cone B. So that's our second step, is to think that they're the same. And step 3, we're going to solve for the height. All right, so let's focus in on cone A now. Forget about cone B for a little while. Focus in on cone A. Now, to get the volume of any cone, we're going to write the generic formula. Since it has a point, because it's a cone, our generic formula is 1/3 big B H. Let's think about what big B is here. So volume equals 1/3. Since our base is a circle, we're going to put in pi r squared H. Okay, now we don't have volume, we don't have V, that's what we're solving for. Pi is a number. We don't have R, but we do have H. Okay, so before we can get this volume, we need to figure out how we're going to get R. Well, let's take a look at what we have. They gave us circumference. You have to know that when they give you circumference, you can quickly work backwards to get the radius. Your circumference formula that you should memorize is 2 pi r. Look at where the r is. It's part of that circumference formula. So let's go ahead and work backwards. Let's get r so we can find the volume of cone A. So our circumference is 6 pi. That equals 2 pi r. And now let's solve. Since pi is on both sides, we can cancel that. And then we just want to get r by itself. So we're going to divide both sides by 2. The 2's will cancel. So now r is all by itself on the right. 6 divided by 2 is 3, which makes sense. Our circumference is 2 times the radius times pi. So 6 is 2 times the radius. So that must mean that the radius is 3. That's pretty straightforward. I like it when they give me circumference with pi. It makes it very easy. So our radius here is 3 for cone A. Now, since we have the radius, we are ready to plug in and get the volume, which is our first step, our goal. Get the volume so that we can then later work backwards to get the height of cone B. All right, so let's plug in. V equals 1/3 pi 3, which is the radius we just found, squared, times your height of 9. I'm not going to multiply the pi in because I know that when we get to B, it's also going to use pi. So it may be easier not to multiply pi in just yet. I'm going to do everything else. So starting with the 3 squared. 3 squared times the height of 9 is 81. And then we have to divide by 3 because of the 1/3. So divided by 3 equals. Okay, so volume equals 27 times pi, because we haven't multiplied the pi in. Great. So the volume here is 27 pi. So that means the volume of cone B is also 27 pi, because they said they should hold the same amount of ice cream. Perfect. Now that I have the volume of cone B, I'm almost ready to work backwards. So volume formula for any cone, just like we looked at before, was 1/3 big BH. Since we already know that big B stands for area of a circle, I'm going to go ahead and write down the same formula that I did before. So V equals 1/3 pi r squared h. Now, before I plug into here, let me think about whether or not I have everything I need. Now, my volume is 27 pi, because we found that out about cone A. My radius, I don't have my radius yet. I only have circumference. And then h is what I'm looking for. Remember, our goal is to get the height of cone B. Okay, so right now our goal is get the radius. Again, since they gave me the circumference, we need to figure out the radius from the circumference. Remember, circumference is 2 times the radius times pi. So 8 is 2 times your radius, which means your radius must be 4. So our radius is 4. So great, let's plug that in. Now that we have r, we can plug everything in and solve for h. So volume is 27 pi, same as we got for cone A, which equals 1/3 pi. Our radius is 4 squared h. So let's focus in on this algebra now. I'm going to zoom in. Okay, first step, I'm going to cancel out the pi's. Once I do that, I have 27 equals 1/3. 4 squared, I'm just going to go ahead and simplify that. 4 squared is 16 times h. Okay, I don't like to see the 1/3 there. So what I'm going to do is I'm going to multiply both sides by 3 to get rid of the 1/3. So 27 times 3 equals 81 equals the 1/3 and the 3 cancel, 16h. And now last step, divide 16 on both sides. So our height is exactly 5.0625. That is the height of cone B. But they want your answer to the nearest hundredth. So our answer is just 5.06. 5.06. Okay, now this was a long question, and I warned you about that from the beginning. Let's take a look at why. Remember, as a quick recap here, we wanted to solve for the height. We couldn't solve for it until we got the volume. Well, we don't have enough information to get volume of cone B, so we had to get the volume of cone A. Before we could get the volume of cone A, we had to simplify the circumference to get the radius. Once we got the radius of 3, we plugged it in, and we got the volume of cone A. We brought that volume over and made sure that we set up our volume formula for cone B again. Then plugged in everything we knew except for h, because that's what we were looking for, and solved for h. So many steps here, but this was our game plan. It all worked out. Okay, let's keep moving. Number 144. The basketball fits snug in the cylinder package shown. The basketball's volume is blank percentage of the cylinder's volume. Fill in the blank. Okay, so let's go to the ask of the question. They want to know what percentage the basketball volume is compared to the cylinder's volume. So the way that you figure out a percentage is like this. You take what you want. In this case, we want to know about the basketball's volume. So you take what you want and you divide it by the whole. Now, in this case, the whole thing would be the cylinder's volume. So really, this is going to simplify to be volume of the ball divided by volume of the cylinder. Once we divide, we get a decimal in our calculator that we then turn into a percentage. All right, let's think about this shape. I'm going to zoom in on it. Okay. We have a ball that fits snug into a cylinder. Now what that means is that the width of this ball is the same as the width of the cylinder. So in other words, the diameter of the sphere is the same as the diameter of the cylinder. And the vertical diameter, so from the top of the ball to the bottom of the ball, okay, this diameter is also the height of your cylinder because it fits snug. It goes to the top of the cylinder to the bottom. No gap anywhere. The only gaps are around the ball. Okay, so I'm going to erase all these markings. And let's look at the formulas that would give us volume of the cylinder and volume of the sphere. Okay, so volume of the sphere, 4/3 pi r cubed divided by a volume of the cylinder. So big BH, we're going to simplify big B to be pi r squared times h. Now look at your formulas. They use two different variables. We have an r and we have an h. We can't use two different variables in an equation and try to simplify it. We got to stick with one variable. So we're going to stick with r, and we're going to express the height of the cylinder in terms of r. Let's take a look at how we do that. Since we know that our basketball fits snug into the cylinder, that means vertically I have this little radius here, and vertically downwards is another little radius. So we have two radiuses up and down, making up the whole diameter of the sphere. Now, instead of calling it d for diameter, let me think about how I would express this height for the cylinder in terms of r. Two r's on top of each other is r plus r. In other words, the height of this cylinder is 2r. So I no longer have to use h. The height of the cylinder will now be called 2r. Okay, let's plug this stuff in. Because remember, I can't use h. I got to use something else. So I'm going to put 4/3 pi r cubed, that's for our sphere, divided by pi r squared times 2r. Remember, we can't use h. Let's simplify this further. So 4/3 pi r cubed, I'm not going to touch the numerator for right now, over. Now for your denominator, I'm going to go ahead and simplify this. R squared times 2r. Well, 2 and the 1 that's invisible in front of the r squared are going to multiply together. So I'm going to bring 2 to the front. I'm going to bring the pi along for the ride. That's not getting touched. But now r squared times r. R squared times r. Algebra recap. R is to the first power. When you multiply r squared times r, you're going to add the exponents, 2 plus 1. So it's r cubed. In other words, think of r squared as r times r, and then you're multiplying it by another r. So r times r times r, those are 3 r's. So r to the third power. So I'm simplifying the denominator to be 2 pi r cubed. And now let's take a look at all the algebra magic that's going to happen. Okay? The pi's will definitely cancel. The r cubes will definitely cancel. It's the same top and bottom. So we're left with 4/3 all over 2. Now, most of you know the keep, change, flip type of thing to divide this fraction, but I'm just going to use my calculator. So 4 divided by 3 equals, divided by 2 equals, and now that's my decimal, 0.6666, yada, yada, yada. Now, if I want to turn this decimal into a percentage, I have to take that decimal, move it 2 to the right, and now we have 66.6 repeating percent. So, to answer the question, The basketball is about 66.6 repeating percent of the cylinder's volume. So my final answer, 66.6 repeating percent, or 66 2/3. That's another way to write it. 66 2/3%. All right, last question on this page. Let's keep it moving. Last question on the page, number 145. Bakery La Panaderia sells 2 sizes of graduation cake as pictured. The smaller cake feeds 12 people. How many people will the larger cake feed? Okay, this is the ask of the question. How many people will the larger cake feed? The smaller cake feeds 12. So I'm going to write 12 people. Now, the larger cake, I'm going to write X people. I have no idea. That's what I need to figure out. Now, when we're talking about feeding somebody with cake, they're not taking the cake and licking the icing, licking the outside. That would be surface area. When you're eating a cake, you're eating the inside. You're eating all of it. So when you're eating something, that's volume. You're consuming quantity. So this question is really rooted in volume. Now, what we need to do is we need to figure out, well, how much volume do 12 people eat? Because then we can keep that consistent and figure out how many people the larger cake will feed. So we need to figure out the volume for both. Now they're telling us the small cake is 10 inches and that 10 inches is our diameter. Our radius. Okay? And then the larger cake is 14 inches for the radius. Okay, so now with these 2 cakes, they have the same height. And what we're looking for is to find their volume, and then we'll talk. How do you figure out how many people will the larger cake feed? So let's start setting up our volume formulas. We've done the cylinder a couple of times on this page. Remember, it's V equals big BH, because there's no big point at the top. Replace big B with the area formula for a circle. So pi r squared h. And now we have for the smaller cake a radius of 10 and the larger cake a radius of 14. Let's go ahead and put this in. So volume equals pi for the smaller cake 10 squared times a height of 8. I'm going to keep it in terms of pi because both of them are going to use pi in the formula. So it may be easier to just not multiply pi in just yet. So in the calculator, 10 squared, which is 100, times 8 equals. So we have 800 pi. And now for a larger cake, V equals. We have again big BH, which makes this into pi r squared h. And now our radius is 14. So pi times 14 squared and then the height of 8. So same thing in the calculator. 14 squared times 8 equals. So 1,568 pi. Those are my 2 volumes. Now, when I'm all of a sudden talking about people or plants or ants and I'm converting volume into gallons or people and doing something weird, we've never taught you how to find people. So what you want to do to stay safe is set up a proportion. Proportions are some of your best friends. All you need to do is think about, if I have 12 people that can consume 800 pi cubic inches of cake, keeping that same ratio consistent, then I should have X people who can consume 1,568 pi cubic inches of cake. So keeping that ratio consistent, that conversion consistent. Let's cross multiply. So in my calculator, I'm going to do 1,568 times 12. That's my first diagonal, equals. So now I have 18,816 pi. I didn't multiply pi in yet. Equals. My other diagonal is 800 pi times x. Now notice the pi's will cancel. So in my calculator, I just need to do 18,816 divided by 800 equals. So now I have 23.52 equals my X value. All right, now, how many people will it feed? Well, it's not going to feed 23.5 people. It'll feed 23. There's going to be a little left over, but it's not going to feed 24. You're not going to round up to 24, because if you said it could feed 24 people, that last person is not getting a full slice of cake. So we're going to stick with 23. We're going to round down. Okay? So 23 people is how much the larger cake will feed. 23 people. Now, some may have assumed that this 10 inches is not the radius, that it's the diameter. You would get the same exact answer of 23 people if you thought the 10 inches and the 14 inches was your diameter, because then your radius would be 5 and your radius here would be 7. And if you tried it out that way, you got the same answer, 23 people. Okay, we are done with page 28. Let's keep moving.